top here. All right, so the Seaborn statistical plotting library is a really nice complement to the Pandas library because it's built entirely within Matplotlib, and it's designed to very quickly and easily create presentation-ready statistical plots from Pandas data structures. So it's designed to take in, it's designed to very simply interface with Pandas data structures so that you can input a data frame, specify whichever columns you want to plot, and just go. And in many cases, the plots that are created by Seaborn are variants of plots that Matplotlib provides, but are much more complicated to implement in pure Matplotlib than they are in Seaborn. And in some cases, there are some plot types that are not available in Matplotlib that you can do very quickly and easily in Seaborn, that are also very handy. So I'm just going to focus on there are like 15 or 16 different plot types that Seaborn provides in total, but I'm just going to focus on the 4 that are the most different from what Matplotlib offers natively, or what would be hardest to replicate in Matplotlib. So we'll also make extensive use of Seaborn's built-in testing data sets, of which there are many. The ones that I use for this talk are primarily the miles per gallon data set, which is about the fuel efficiency of a certain subset of cars from, I think, the last 10 years or so, or from the mid-aughts, or from a 10-year period in the aughts to the early teens. And then there's like a Titanic data set, which covers how many Titanic passengers, or basically the names and ticket classes and sexes and all of the other demographics of various Titanic passengers and whether or not they survived. So some of these data sets are commonly used to test machine learning algorithms, but they're also built in to Seaborn to test different plotting libraries. Just one note before we get going, there is Seaborn has a built-in regression function that you can use to look at linear regressions of certain data sets very quickly, but you should not rely on that. Seaborn does not return any of the parameters needed to assess the quality of the fit. And even the official documentation warns you that it's just for quick and dirty visualizations to motivate proper in-depth analysis. What is going on there? So anyway, loading and running Seaborn, I think actually pretty much all of these commands are the same that you would have loaded if you attended the previous Pandas lecture. So you would need to, if you're using an Anaconda distribution, you may still need to import Seaborn separately, but I think it's included in Anaconda. But if you're using a pip distribution or a non-Anaconda distribution, then what you would need to do is load all the prerequisites for Python, load the SciPy bundle to get NumPy and the basics like that. Load Matplotlib. On HPC2N, I think you also need to load tkinter explicitly in order to use Matplotlib and use the right backends for Seaborn, and then you can import Seaborn. What the heck happened there? Something's going wrong here. I don't know what happened there. I'll have to troubleshoot that later. It's going to be fairly similar on every machine. So on LUNARC, On LUNARC, Matplotlib, or on LUNARC, the only difference between here and or what's listed here and what's on LUNARC is that you don't have to, is that Matplotlib pulls in tk-enter by default. And everything else is going to be pretty much the same as you already saw in the pandas lecture if you attended, but then you typically have to import Seaborn separately. The Seaborn libraries all start with all the versions that are typically available right now are like 0.12 or 0.13. They start with a 0. In most cases, when you look at pandas documentation, you'll see it abbreviated as SNS because Seaborn is named after some character in the West Wing whose initials is that. That's fine if you want to. I use SB because that's what I can remember. I never watched West Wing. But anyway, so I mentioned a little bit about sample data sets. A couple of popular ones are penguins, Iris, Titanic, miles per gallon, which gives information about model year, physical characteristics, engine specs, and fuel economy of a variety of cars. Planets, I've actually submitted a sanitized version of the exoplanets database that you worked with as a revision for this. Hopefully it'll, the owner of the repository said it might be getting updated soon. I don't know. So far it has not though. For most of this tutorial, we'll use the MPG and Titanic sets. So there are a few common characteristics across the Seaborn plotting libraries. They're all designed to take pandas data frames and sometimes series as inputs. So as such, different plot types share some of the same quarks. Most of them you have to pass the main data frame as the first argument, and then that tells it where to search. That tells the Seaborn function where to search for the remaining quarks. Either way, it's usually mandatory. Usually they have an X and a Y, sometimes just an X. That gives the names of the columns that you want to plot against each other. These are usually necessary, but if you're not plotting, not if you're plotting every possible pairing of numerical data columns all at once. That's something you would do with like a pair plot or a heat map function. Then I wanted you to take a special note of this quad called hue. This accepts a categorical variable, and that lets you plot multiple data sets on the same plot in a different color. This is really handy for comparing different categories. The default palette is usually fine if you have less than a handful of categories, but if you want to change them, you can do so with seaborn.color palette and then name a palette that's described in the official documentation. Or you can pass it your own color list. And finally, there's this axis quad, which takes the name of an axis object if you want to add Seaborn plots to as a subplot to an existing figure. We talked about the figure and axes level interfaces yesterday in the map, or not yesterday, last Friday during the Matplotlib lecture. So I'm not going to spend much time on this. If you didn't see that lecture, go to this link and you can look at the pros and cons of different APIs. Just a quick caution for those of you who are trying to plot for publication. Seaborn typically titles axes by the variable names or by the column names as they appear in the data frame, which means if they've got underscores or incorrect typesetting or other non-optimal characteristics, that will show up in your plot, and you will have to manually override them. And so in a little bit, I'll demonstrate one way to fix the axis label formatting. Anyway, whoops. So I'm as I said, we'll be focusing on four plots that I think are the hardest to replicate in MATLAB or Matplotlib, if at all possible. So what I'll show you is joint plot, pair plot, heat map, and the violin plot. There is a Matplotlib version of the violin plot, but the Seaborn version I think looks much nicer, and it requires much less work. The rest of these do not have a direct Matplotlib equivalent. They are implementations of things that would be very complicated to replicate in Matplotlib. So let's start with joint plot. This is where you would plot two variables against each other and have small histograms of each variable along the top and right. There was a demo of this in pure Matplotlib that I think I skimmed over in the Matplotlib lecture. If you looked at that later, you might have seen how complicated that was to create. For Seaborn, it's one line. Once you have the data frame that you need, it's literally just Seaborn.jointplot, input the data. In this case, it's a kwarg instead of an arg. Give it the x value. I gave it the weight column of the miles per gallon data frame. For the y column, I gave it the actual miles per gallon from the miles per gallon data frame. And for hue, I decided to use the country of origin. That was a categorical variable in the original data set. For marginal ticks, when I set marginal ticks equals true, what that does is that turns on the y-axis labels on these marginal plots, which was not a great idea for these here at the bottom, but anyway, so for Seaborn, I didn't even have to for just the Seaborn plot, if you don't care about what the x-axis and y-axis labels are, I didn't even actually have to import Matplotlib. You might have to if you are depending on the version of Jupyter Notebook that you're using, but I only had to import Matplotlib in order to update the x and y-axis labels. I'm seeing a lot of comments in the chat, so it looks like people are having trouble with Seaborn installations. So it looks like something definitely went wrong between last time and this time that I didn't notice. Anyway, but thankfully Bjorn is handling it. Anyway, so that's this example, and you can see that on the whole, according to this plot, the U.S. made cars trend towards much heavier weights and lower fuel economies than the cars that were made in Japan and Europe, which tend to cluster closer to the don't have as wide of a distribution. So by default, the main plot is a scatter plot, but you can, and the marginal plots are either histograms if the data are not shaded by a categorical variable, or kernel density estimations if the hue kwarg is specified. So up here, if I had not separated out the data by country of origin, these plots up here would have been the typical step histograms. And there would have just been the one. So you would have seen maybe a stair here, a little gap here, and then a bunch of stairs all the way up to 6,000 pounds. But because I used the hue kwarg, it automatically converted these the curves to kernel density estimations, or KDEs. Those are basically histograms smoothed by convolution with usually a Gaussian kernel. So it's basically treating each point as a Gaussian of units, height, and standard deviation. But you can also give the center. You can give the center plot a different form. So you can use the kind quark to set it to tell it to be like a 2D histogram. You can make it a hex bin plot. You can use KDE, which in this one will plot contours. And then there are also reg and resid options, which those keep the scatter plot but add a linear regression and trend line. Or residuals does the linear regression internally and makes the scatter plot with the data having already had the trend subtracted. So, but the reg and resid arguments cannot be used with hue. Anyway, so that's all well and good. But what if you have a whole bunch of variables that you want to do the same sort of analysis with? Well, you can use pair plot or pair grid. Most of the time, it's enough to use the pair plot function, but you can use the underlying more customizable pair grid function if you need more customization. I'm just going to cover the pair plot function here. So first, for the miles per gallon data sets, I'm going to show you the number of variables, which ones are, and see which ones are unique, and whether any of them can be used as are fit to be used as the hue argument. So there's about 5 or 6 numerical variables. In this case, that would probably all fit on a page just barely, but if you have more than that, many numeric variables, you probably need to choose only a subset in order to fit on a journal page. For this one, I've dropped cylinders, model year, and name, and just keep the origin for hue. And so then I'm showing this, starting with just plotting this temporary version of the miles per gallon data set with dropping these 3 columns. So then this is the plotting command. I've just set the data equals this temp, set the diagonal kind equals to KDE, set corner equals to true, and the second you'll see what that looks like. The result looks like this. Let me see if I can't zoom out just a little bit. Nope. So what corner did was that by setting corner equals true, I turned off the top corner here. If you wanted to, you could leave the corner on and use the top corner to show a different representation of these data. For instance, if you wanted to show the contours, or if you wanted to show these data sets as contours, which can make them easier to see the overlaps. Now let's look at how much it takes to actually fix all the labels. It's all of this. So most of the time, if you're going to be doing a pair plot or pair grid, you'll be spending the vast majority of the code. If you're doing this for publication, you'll be spending the vast majority of the code just fixing the labels, not actually on the plot itself. So let me go back up here and let me go over here to the code that I used to produce it, and I will show you what the original labels look like. So you can see they're all lowercase. None of them have units, which that's perfectly fine for if you're just wanting to visualize them and not have them for publication. But you still want to format them and include the correct units for publication. So let's see what other data. How else can I change this? I could use, let me show you hexbin. No, that would not be it. That would be, let's show you what hist looks like. So if I use diag kind equals hist, now what you see is that I've converted these diagonals to the standard sort of step histogram looking things. That's not, I don't prefer that. I think KDE looks better, but that is an option. And here's this version. So if you want to, if you want more customization, you can use the pair grid version, and you can use, once you've initialized the pair grid, then you can call, what that does is that it creates the pair grid without plotting anything just yet. And then you use and then you call a command off of it that is usually of the form .map underscore and then a position. So there's .map underscore diag, which handles data along the diagonal. Then the upper off diagonals are handled by map underscore upper, and map underscore lower handles the data below the diagonal. And so for each of these, it takes Seaborn's version of a standard pairwise plot type, and it casts the variables to their respective subplots in the form of the plot that you give it as a kind. So for each of these map position functions, you can pass it a plot type as a string. Well, no, not as a string, as a Seaborn.hist plot or Seaborn.kde plot or Seaborn.scatter plot. There's also eCDF plot if you want that. Here's the sample plot again. The only reason I have to keep copying the loading and changing in here is because of how it works in this little website. So the main plotting command is here. When I set dspine equals false, what that's doing is that that's adding the right and top borders to each of these plots. Again, I'm still coloring the data by hue equals origin. I've turned off share Y. Then for each of these, so for the diagonal, I'm setting this to a histogram plot. I'm using this multiple equals stack so that it arranges them lowest to highest so that you can see all of them, and then stacks them on top of each other. And then this element equals step, that's just changing the formatting of the histogram. And then on the upper off diagonals, I've set these to show what the KDE plots look like. So as you can see, they look like kind of piles of circular spaghetti. And the default number of contours might be a bit much, but you get the point. And then you can see the original scatter data that was used to produce these KDEs on the lower off diagonals. And I haven't bothered to format the labels here. Anyway, so for the map commands, the quarks can depend on the type of plot that was passed. When his plot is passed, you can use this multiple and element quarks to offer nice ways to adjust the appearance so that they display well as layers. I already went over these. KDE KDE and scatter plots have their own quarks to control things like line styles and markers. Unlike most of the other plots here, pair plot and pair grid do not have an ax quark because they're already multiple subplots. So these have to be their own figures. And okay, so the next plot type that Seaborn offers that's really handy is, well, there's two. There's heat map and cluster map. They're very closely related. So this is something that you might use if you have, for instance, too many variables to look at with pair plots and corner plots, and you just want to look at the correlation coefficients between different parameters. You can also use this for other things, like if you have two columns that have this, if you want to plot the values of a whole bunch of rows and columns at the same time, and if the cell values are have a sort of physical meaning in terms of if for instance the columns and rows have all the same units, you might choose to plot them on a heat map to compare both rows and columns at the same time. So the miles per gallon data frame can't be used directly as it is, but you can use it as a correlation matrix. And there's a .core method that you can call off of data frame to look at that. So let's see what cluster map and heat map look like for the numeric columns of the miles per gallon data frame. So taking the correlation of just the numeric columns, turning on annote is what that does is that turns on the numbers here. If you plot this on your own and you turn on annote and the numbers only appear in the top row, that's a bug in one of the Seaborn versions. I believe it was 12.1 that has that issue. So you, I know it's fixed by version 13. So it's, if you discover that issue, just bump the version up or down and it should fix it. What this format quark does is that controls the format of the numbers that show up when you use annote equals true. Color map, you can give whatever you want. I actually didn't have to use this. I think it picks the, actually that is something I would like to check. What does this give if you don't choose that? It might be Veritas, it might not be. No, it's magma. Yeah, so unlike matplotlib, Seaborn picks a different color map by default, which in this case is magma. But if I want to go back to the matplotlib default, which is Veritas, we can do that. It's both of those, I believe, are chosen to be. I don't think actually the default Seaborn version is identical to the standard magma, but it is designed to be monotonically increasing in brightness. So it's still fine. And then for these color bar quarks, for the color bar quarks, all I did was assign the label to the color. All I did was assign the title to the color bar, so you can tell what that looks like. Now, oh, that's what I did wrong. So if I do this as a cluster map instead, what that does. What that does is that it tries to rearrange the cells so that sort of like is next to like. So if you have a whole bunch of nearly perfectly correlated variables, they'll all be grouped together, and then if it breaks into another group that's that's strongly anti-correlated, those will be broken up. And then it kind of, and then if there's a third group that's weakly correlated or anti-correlated, it will sort those separately. But basically, what you can see what it's trying to do. It's grouping similar values together so that they so that you can identify trends more easily. And then it very helpfully puts in these square brackets so you can show how it sort of divided stuff up. That's sort of a visual representation of its internal decision tree. Yes, in the instructions, yeah, that was a typo. If you change one of them to cluster map, it does change. It's the same, and the parameters are pretty much the same between the two. Cluster map, the only difference between cluster map and heat map is that it does this grouping. Anyway, so sorry for that typo. There's also VMIN and VMAX quads if you want to adjust the limits of the color map, and a mask quad if you want to map specific squares. There's lots and lots of color, lots and lots of different quads that you can use for these. It's 12.2 that has the bug. It has a bug that causes heat map and cluster map with anode equals true to only label the top row. That's fixed in later versions. And finally, I want to show you violin plots and the like. There are a couple of different variations on the box plot and violin plot mold. There's swarm plot, which is essentially a scatter plot shaped like a violin plot. And then there's this box-in plot, which is like a hybrid of a box plot and a histogram. Those do not have any matplotlib counterpart. But those with matplotlib counterparts, like the violin plot, are much easier to make with Seaborn. And that's partly because Seaborn makes it so much easier to color different data sets. And whereas matplotlib requires you to essentially draw separate patches to overlay on the underlying violin plot and color those in individually. By default, the violin plot shows only the median limits and the KDE of the distributions in a uniform color, and also overplots a thin box and whisker plot without the flyers. That's what this black strip is here. That shows the quartiles. So the thick quartiles are the 25 to 50 percentile and the 50 to 75 percentile. So the second and third quartiles are the thick parts, and the first and fourth quartiles are the thin parts. And then the little white tick mark is the median. But again, you can use the hue to split different data sets into different colored violins, and it offers this split feature which allows you to show a second categorical variable on the same plot, as long as it only takes two values. So for this, the better data set to use is the Titanic data set. And one of the very noticeable discrepancies between the two, the different populations are the survivorship depending on the ticket class. So here I'm showing basically the population distributions of both the surviving and the deceased, the passengers who survived the wreck and the passengers who went down with the ship. So you can see in third class they look pretty similar. In second class, you can start to see a heavy tail, and then and also you can see different Here I've also decided to use age as the Y variable. So you can see that survivorship skews younger for the third as you go to lower classes. And now let's look at the split feature. So here I've decided to, here I'm basically doing the same split again, but using split equals true. So instead of having two separate violins for each of these, they now have one half of the violin is put on each side. And that makes for a more condensed plot where you can see stronger wiggles. And also sometimes it helps to put the two halves closer together so you can see the differences between the KDEs more clearly. So let's look at that. And here I'm going to change hue to, I'm actually going to change hue to sex. And now I'm going to put split equals true. Now this is so this is just aggregating all of the Titanic passengers, whether they lived or not, and viewing their ages and their ticket classes and sex, all in the same plot. So, and this is something that you could plot yourself very easily. All you have to do is once you've loaded Seaborn, you can just do load data sets, pick out Titanic, and then run this code. And you would get exactly the same results. There are dozens of other quarks to control the appearance and similar elements, but I'm leaving that to you because in the interest of time. The one other plot that I'll show you is the swarm plot. And this is nice if you have if you don't have that many data points and you want to see more clearly how they're distributed, because the KDE or box plot might smooth out important small scale features. So here I'm doing it again with the Titanic data set, same arrangement, and coloring them by whether or not they survived the wreck. And then this is what the swarm plot looks like. And now you can see that the age distributions are a little bit more spiky, if that matters to you. And for the second and third class, or for the first and second classes, and the third classes, they're a bit more smooth, probably because the third class was by far the largest, so you have a better sampling. So key points. Seaborn makes statistical plots easy and good looking. Seaborn plotting functions take in pandas data frames very cleanly, and sometimes the names of variables in the data frame to extract as X and Y, and often a hue variable a hue quark that makes different subsets of the data appear in different colors, depending on the value of a given categorical variable. And you also get free data sets to play with. The main drawback of Seaborn is that typesetting axes labels can be a bit difficult and complicated. So in the last 5 minutes, I'll take questions.